Okay, students, this is the second page, or actually the back of the page for the Algebra 1 CBA or test review for October the 9th. I'm going to try to get through this side a little bit more quickly, so I'll be hitting some highlights. Hopefully it will help you be able to work through the entire thing if you have not already. I hope that you've made some progress on it for yourself. Hopefully this will help if your progress has been limited. The first thing that it asks for on number 13 is a set of ordered pairs. Anytime you have a set, let me see if I can draw this a little better with this stylus. Set has a curly brace, and then ordered pairs are in parentheses. So the first one we always start with the one to the negative side. So that ordered pair is -5, 0. So -5 on the X, 0 on the Y. Our next ordered pair is at 3, actually -3 on the X, and -2 on the Y. Our next ordered pair in the progression is a -2 on the X, -2 on the X, and +7 on the Y. On these, it really doesn't make any difference which one you do first. I'll do this one. This is +1 on the X. -5 on the Y. And then for the last one, you have 1 on the X, +2 on the Y, so you then close that parenthesis and close in with the brace. So in listing, in the table, your ordered pairs, your X's go on the left, your Y's go on the right. So all of our X's, we've got -5, -3, -2, 1, and 1. We're not going to put the other 1 in the table. Actually, we can go ahead and do that. We just won't do it on the mapping. With -5 we have 0. With -3 we have -2. With -2 we have +7. With the 1 we have a -5. With the other one we have a +2. Then looking at the mapping, we have -5, -3, -2, and 1. We don't have to do the repeat on the mapping. Then on the Y, we have 0, -2, +7, -5, and 2. Let's take a look at how those map out. 5 goes to 0, -3 goes to -2, -2 goes to +7, and then 1 goes to -5, and also to 2. So we know that's not a function because our x values repeat. In order for it to be a function, 1 cannot be both -5 and +2. Alright, so let's go on to the next section, where we are cleaning up a polynomial. It says to perform the operations on the polynomial, write the expression that is equivalent to it. So let's blow this up a little bit so we can take a look at it. So we have 6a squared plus, and we have a plus that's distributed to everything and it doesn't change the signs. So that's 4a minus 2a squared minus 3 plus 6. Now we have a negative sign that distributes, and it does change. It becomes the opposite sign for everything. So negative a squared, positive a, negative 4. To simplify it, you're just putting everything that looks alike together. Remember, when you're combining, that's adding or subtracting, and so everything must have the same last name. That means they have different coefficients or numbers, and that's where the addition subtraction comes in. But the last name, or the variable with the exponent or whatever's after the coefficient, that is its last name. So things must exactly be the same, or be exactly the same, in order to add them together. So we have the a squares. So we have 6a squared, negative 2a squared, and a squared. That a squared is like 1a, negative 1a squared. So negative 1 and negative 2 plus negative 2 gives us a negative 3a squared that we subtract from positive 6a squared, leaves us with positive 3a squared. That a almost looks like Q. I apologize. The next thing we have are the a's. We have positive 4a, and we have positive a. Positive 4a and positive a gives us a positive 5a. Now all we need to do is combine our numerals. So negative 3, positive 6 gives us a positive 3, and then minus 4 gives us negative 1. So our simplification is 3a squared plus 5a minus 1. Now I'm going to do one of these just so that we can see how this goes. If the perimeter of a triangle is perimeter equals 9b squared plus 4b minus 5, find the missing side if two of the sides are given. So very simply, what we're going to do is combine the two sides that are given and then subtract it from what we know. So that'll give us this third side. So in looking at this and this, when we combine those together, they don't both have a b squared. There's just a b squared of 5b squared. A negative b and a positive 13b is a positive 12b. And a negative 2 and a positive 6 gives us a positive 4. Now, what we're going to do is subtract that then from what we've got up here at the top. When we subtract, what that basically does is put that in parentheses. We're subtracting this polynomial that we just made from the polynomial that exists right here. So what that's going to do is it's going to change the signs of everything on the inside. So let's put those in a cleaner format here. When we distribute this negative inside, we get minus 5b squared minus 12b minus 4. So then 9b squared minus 5b is 4b squared. Positive 4b and a negative 12b is a negative 8b. And a negative 5 and a negative 4 gives us negative 9. So that tells us that this third side then is 4b squared minus 8b minus 9. So let's double check that and make sure that all of our addition and subtraction is correct. So 5b squared and 4b squared give us 9b squared. Our negative b, 13b, and negative 8b give us positive 4b. And then our negative 2, negative 9, positive 6 give us negative 5. So it all worked out. So this is the answer.